Have you ever wondered what significant changes happen to Earth every 24,000 years? Imagine Earth not just as a planet orbiting the sun, but as a performer in a grand cosmic ballet. The stage is set with stars and galaxies, and Earth executes a subtle yet profound dance known as the Precession of the equinoxes. This is a graceful wobble in Earth's rotation, a slow gyration of its axis that unfolds over approximately 24,000 years. What triggers this celestial pirouette? It's primarily due to gravitational forces exerted by the sun and the moon on Earth's equatorial bulge. As Earth spins, these forces induce a torque that causes the planet's axis to trace out a conical shape in space. This motion alters how Earth aligns with the stars and constellations. For instance, today's North Star, Polaris, won't always hold that title. In about 12,000 years, the title will likely pass to another star due to this very precession. This cosmic dance affects more than just the stars in our night sky. Imagine if winter and summer swapped places. This might sound like a premise for a fantasy novel, but it's actually a phenomenon rooted deeply in the mechanics of our Earth's long-term astronomical cycles. It's all about a subtle dance called precession. Precession refers to the gradual wobble in the Earth's rotation on its axis. Picture a spinning top as it starts to slow. It doesn't just spin perfectly upright but begins to wobble slightly. Similarly, Earth's axis wobbles over a cycle of about 24,000 years. This wobble changes the orientation of Earth's axis in relation to the sun, thus altering the timing of when each hemisphere is closest to the sun. Now, why does this matter? Because it affects when we experience our seasons. Typically, the proximity of Earth to the sun during a particular hemisphere's summer leads to warmer temperatures due to more direct sunlight. But, as precession shifts the axis, the point in Earth's orbit where it's closest to the sun also shifts. This means that over thousands of years, the seasons themselves can shift. What is now winter could become a warmer season, and summers could turn into colder periods. This long-term shift could lead to dramatic changes in climate and seasonal patterns. Regions accustomed to certain agricultural schedules and ecological conditions may find themselves needing to adapt to a completely transformed environment. So our distant descendants might experience a very different December. Ancient civilizations were not just building monuments, they were marking time. As we delve into the enigmatic world of ancient megastructures, we uncover a striking connection between these constructions and the cosmos. Take Stonehenge, for instance. This prehistoric marvel isn't just a circle of towering stones, it's a sophisticated astronomical calendar. These structures were meticulously aligned with celestial bodies that have subtly shifted their positions in the sky due to the slow waltz of precession. Such alignments were far from arbitrary. They served critical roles, guiding ancient peoples in agriculture, knowing when to plant and harvest, and marking sacred times in their spiritual calendar. Imagine planning your year around stellar movements using giant stone structures as guideposts. This deep-rooted celestial connection highlights the profound understanding ancient cultures had of the cosmos, an understanding that was vital for their survival and rituals. In appreciating these alignments, we realize that these ancient astronomers were more sophisticated than we often give them credit for. It's not just humans that notice these changes. Every 24,000 years, as the Earth subtly shifts on its axis, an entire world of wildlife faces a silent recalibration. This phenomenon, known as precession, subtly alters the celestial navigation cues that countless species rely upon. Take migratory birds, for instance. These avian navigators use the stars as their guides on long journeys across continents. As the positions of the stars slowly change due to the Earth's precession, these birds must adapt their internal compasses. This isn't just about recalibrating their routes, it's a matter of survival, ensuring they can find their traditional breeding and feeding grounds despite the shifting skyscape. Marine life, too, is profoundly affected. Many marine species, such as coral and certain fish, rely on lunar and solar cycles to time their spawning events. The subtle changes in the timing of lunar phases and solar positions can disrupt these critical cycles. This disruption might lead to mismatches in the timing of breeding, which can have cascading effects on the ecosystems that depend on these species. Even terrestrial animals are not immune. Many species use the length of the day, which can be influenced by these celestial shifts, to trigger migration or hibernation. Changes in these cues can lead to premature or delayed migrations, affecting food availability and survival rates. As the stars shift, so too must the natural world adapt. In this dance of celestial mechanics, the resilience and adaptability of Earth's wildlife are continually tested. Shifts above stir changes below. As the Earth undergoes its grand precessional cycle every 24,000 years, not only do celestial patterns shift, but so too do the foundational elements of our planet. The precession of the Earth's axis has profound implications for geological and atmospheric phenomena. Take ocean currents, for instance. These massive movements of water regulate climate by transporting heat across the globe. As the tilt and orientation of the Earth's axis change, so too might the routes of these currents. A slight shift could alter the flow of the Gulf Stream or the jet stream, which could lead to significant changes in climate patterns across continents. Wind patterns are equally susceptible to these shifts. The trade winds, westerlies, and polar easterlies could change in intensity and direction. This alteration can transform weather systems, potentially increasing the frequency and intensity of storms or conversely leading to unusual periods of calm. On a more solid note, the stress exerted by changes in gravitational forces and shifts in the Earth's crust could potentially trigger geological events. While it's a subject of ongoing research, some scientists hypothesize that precessional cycles might influence seismic activity, possibly leading to an increase in the occurrence of earthquakes in certain regions of the world. These changes are not merely academic, they hint at a dynamic Earth, responsive to the cosmic dance of our solar system. Indeed, the very ground beneath us responds to the movements in the heavens. How will humans in the far future adapt to these celestial shifts? As the Earth pirouettes in its grand cosmic ballet, the subtle yet profound impacts of precession redefine our world every 24,000 years. Imagine a future where our descendants face landscapes that shift slowly, but inexorably. How will they adapt? The answer lies in the boundless realm of human ingenuity. Future societies may harness advanced technologies to reshape their environments. Agricultural practices, for instance, will need to evolve as growing zones migrate with the shifting climates. We might see crops genetically engineered to thrive in diverse conditions, or innovative farming techniques such as vertical farms that maximize space and resources in changing weather patterns. Urban planning will also undergo a metamorphosis. Cities of the future might be built to be highly adaptable, with structures that can modify themselves based on environmental conditions. Picture buildings with exteriors that adjust to optimize temperature, or entire cities designed to migrate slowly in response to long-term climatic shifts. Geopolitically, the map of the world could be redrawn as nations respond to the redistribution of natural resources. Water scarcity might lead to new alliances or conflicts, and nations may shift their focus from competition to collaboration, developing shared technologies and strategies to manage the ecological and economic impacts of precession. In the spectrum of human history, 24,000 years is but a brief moment, yet it is long enough for monumental transformations. Our ingenuity will be key in navigating this slow-motion transformation. As we've seen, Earth's 24,000-year cycle is a journey through time and space. Delving into this celestial rhythm, we first explored the precession of the equinoxes, a subtle yet profound wobble in Earth's rotation. This motion, unfolding over thousands of years, alters the alignment of our planet with the stars, reshaping our experience of the seasons. Imagine the winters growing milder, the summers more intense, all in a slow-motion dance dictated by the cosmos. We then turned our gaze to the ancients, who, under starlit skies, first noticed these celestial shifts. Their observations, etched into stone and story, were not just for intellectual curiosity, but survival. These early astronomers could predict seasonal changes, ensuring their communities thrived by aligning agricultural practices with the stars. The ripple effects of Earth's prolonged pirouette extend into the realm of wildlife as well. Migration patterns, breeding cycles, and even the distribution of species across continents are tuned to this grand temporal symphony. As the Earth tilts and teeters, habitats evolve, prompting species to adapt or wander in search of more favorable conditions. Beneath our feet, the geological and atmospheric narratives tell yet another tale of transformation. Over millennia, shifts in climate sculpt the landscape, crafting new environments and altering existing ones. Volcanic activity, ocean currents, and atmospheric composition, all are players in this unfolding drama, each influenced by the slow twist of our planet. Turning to humanity's own saga, the impact of these celestial mechanics is seen in the migration of cultures, the rise and fall of civilizations, and our perpetual quest for understanding and adaptation. From the construction of monumental structures aligning with the stars to modern scientific endeavors that peel back layers of time, our species has continually adapted to, and been shaped by, these cosmic forces. In reflecting on this perpetual journey, consider the broader implications for Earth and its inhabitants. Every 24,000 years, Earth reveals a new facet of its intricate dance through the cosmos. What might we discover next?